Let's take a look at this example on total differential. It says the pressure P, volume V, and temperature T of a gas are related by PV is equals to KT, where K is a constant. Determine the total differentials dP and dt in terms of PV and T. Okay, let's begin with dP. Now, the first thing to do is to make P subject to formula. Therefore, P is equal to KT divided by V. Remember that K is a constant. So we can write our expression of dP to be equal to partial derivative of P with respect to T multiplied by dt plus partial derivative of P with respect to V multiplied by dV. Because P is in terms of K is a function of T and likewise of V. So we are now asked, we will now be required to evaluate the P dt and also be required to evaluate the P dV. Now the P dt of KT divided by V is equal to, that means we are going to look, T is a constant, we have to keep K over V as a constant, and now a full differential with respect to T of T, and that is K over V multiplied by 1, which is K over V. And likewise for dP dV of KT over V, realize that KT is a constant and we have a full differential with respect to V of 1 over V, and this is KT multiplied by minus 1 over V squared, because 1 over V is the same thing as V raised to power minus 1, and this will be minus KT divided by V squared. Therefore, we can now evaluate our dP, which is partial derivative of P divided by partial of T multiplied by dt plus partial derivative of P with respect to V multiplied by dV. Then we'll make our substitutions. dP dt is K over V multiplied by dt. dP dV is minus KT. Okay, this can become minus KT over V squared dV. Now, we are asked to leave our answer in the terms of PV and T. Now, since PV is equal to KT, then we can have our a substitution of K to be equals to PV over T. So we can substitute PV over T, and our dP will be written as PV over T divided by V, or multiplied by dt minus PV over T multiplied by T divided by V squared of dV. In conclusion, our dP is equal to P over T dt minus P over V dV. Now this is just one part of the question. Let's move to the next part. And in the next part, we are required to evaluate dt. So the first thing we have to look for is to make t subject of formula. I'm making t subject of formula in the equation given. T is equals to PV over K. Now with that done, we can now write a differential of dt because t is a function of both p and v. So dt will be dp or dt divided by dp multiplied by dt multiplied by dp plus dt divided by dv multiplied by dv. So let us evaluate dt, dp, and likewise dt, dv. dt dp of pv over k. That means v over k is a constant, and we have a full differential with respect to p of p, and that is v over k multiplied by 1, which is v over k. And the same is applicable to d dv of pv over k, where we have p over k as a constant, and we are differentiating fully now of dv of v with respect to dv, and that's p over k of 1 p over k. Therefore, formulating this formula, we have that our dt is partial derivative of t with respect to p, which is v over k multiplied by dp plus partial derivative of dt of t with respect to v, that is p over k multiplied by dv. Now, since we are required to leave our answer in terms of p, v, and t, we have to make a substitution of k. So we recall that k is pv over t. So let's substitute our k. Therefore, dt is v divided by pv over t multiplied by dp plus p divided by pv over t multiplied by dv. Simplifying further, we have that dt is t over p dp plus t over v dv. In our next video, we'll be taking a look at rate of change, and we'll be building on the knowledge we have gained on total differential.